This week we are learning about the evolution of atomic theory. So before we talk about how scientists came to know, or sort of know at least, how atoms are set up, let's talk about what they are. Atoms are the basic building blocks of all matter. So your pencils, your desk, your skin, your eyeballs, your shoes, anything that is a thing, right? It has mass and it takes up space is called matter. And matter is made up of these tiny little, less than microscopic things called atoms. Okay, and in the middle, we have something called the nucleus. Okay, and inside the nucleus, we have two different things. You notice there's little guys with plus signs, there's little guys that are blank. The little guys with plus signs are protons. Protons are positively charged particles. Neutrons have no charge. They are neutral. Sort of like when you're driving a car. When you learn to drive your car, you put the car in neutral. It's not going forward. It's not going backward. It's just there. Protons and neutrons have a lot more mass than electrons. Electrons have a negative charge. Okay? And then so the nucleus in the middle with your protons and your neutrons, and then your electrons are in the outside space called the electron cloud. Okay, so that is what an atom is. And based on how you know things work, scientists didn't always know that's the way that it's set up, or that's the way we believe it's set up right now. Again, science is changing all the time. This could change. So let's start with the beginning. Democritus was a very old, or old I say as in like a long time ago, before 400 BC, roughly. He's like, okay, there's these things called atoms. They're made up, there are these tiny little particles called atmos, meaning atmos means that it can't be divided. So he believed that it is the smallest thing. We couldn't go past that. So he thought it was a solid, homogeneous, meaning it was the same all the way through, and that he said it again, indivisible, meaning we couldn't cut it. The word atmos literally means uncuttable. We could not cut it into smaller pieces. So he was saying that different matter is made up of atoms of different sizes and shapes. So he believed that atoms could be different sizes. They also could be different shapes. And changes in matter. Okay, so if I burn something, or I combine sodium and chlorine together and I make salt, sodium chloride, he thought it was changed by, or caused by, changing groupings of atoms. Some of that is correct and some of that's not correct. So then a little bit later, so we go from 400 BC to 332 BC, and it's backwards because remember that when you're in BC time, before Jesus Christ, right, this is like negative. So 400 years before Christ versus 332 years before Christ. Democritus is much further away than Aristotle. So we went a little backwards here. Aristotle said there is no evidence that atoms exist. Everything is made of earth, fire, wind, and water in different combinations, and that's it. So Democritus had this model where it's just a tiny solid like ball. And I said that Aristotle had no model because he didn't even think atoms were a thing. He didn't think they were real. So that's it. Okay, then Aristotle messed us up for a long, long time. So before Jesus Christ to now in the year 1802, so after, almost 2,000 years later, it took us 2,000 years to figure out that atoms are, or to go back to believing in atoms. So John Dalton says, going back to sort of what Democritus was saying, atoms are smooth, hard spheres. Notice that his model and the model for Democritus are basically the same concept. So kind of think of a bowling ball, solid sphere, can't be divided into anything else. So the atoms in an elements, remember things like gold, silver, hydrogen, helium, oxygen, specific things. The atoms in an element are unique from atoms in different elements. So oxygen atoms are different from hydrogen atoms, or different from helium atoms. The atoms of one element can't be changed into atoms of another element. Again, some of this is true, some of this is not true. It's just what we thought at the time. So he said, when atoms combine together in different orders and different groups, we get compounds. Okay, think of salt, sodium and chlorine. So we go from 1802 now to 1897. So we're making progress less than 100 years later. So we've got this guy named J.J. Thompson, and he discovered electrons. Okay. He said atoms are gel-like positive matter. And then, so kind of think of the pink red part of the watermelon. Okay. And that that's all positive, and the negative electrons are embedded in the positive part. So think about the watermelon seeds, the little black seeds here, those are electrons embedded inside of the watermelon fruit. So that's sort of what his model was like. He called this the plum pudding model. Okay, I compared it to a watermelon because we don't eat plum pudding in the United States. This was something in England. Plum pudding was this weird thing that they had. It was like a weird cake with like raisins or whatever the heck that was inside of it. Okay, so then he was thinking that the little raisin looking things inside of the plum pudding was those were the electrons. Now go from 1897 to 1911. So again, we're shortening time here. So Ernest Rutherford says, okay, let's go a little step further. Atoms are mostly empty space. He was a former student of Thompson's. So J.J. Thompson taught Ernest Rutherford. So Ernest Rutherford took what Thompson taught him and went a little bit further, and he performed this gold foil experiment. And we're going to watch this together in class. You can click on it here and click on that, and it will take you to the YouTube video for you to watch. So atoms are mostly empty space. Electrons move around a positive nucleus. So his model looks like this, where the nucleus is in the middle, and there's so much extra room in here, and the electrons are going around the outside. So think of it, if you've ever had a real cherry, not a maraschino cherry. A real cherry, there's a pit in the middle, which represents a nucleus, and then the fruit is kind of where the electrons are found. That's Ernest Rutherford, so 1911. Then, only 2 years later, so we had Ernest Rutherford taught Niels Bohr. So just a couple years later, Niels Bohr's like, okay, well, I don't really think your model is totally accurate. He took this model and went further and said that electrons exist in these energy shells around the nucleus. And he said electrons don't change the levels. And think of tree rings or planet orbits going around the sun. That's kind of the idea here. So thinking that protons are in the middle and electrons are on the outside. Notice that if we go back to our original diagram, so far we've discovered protons, we've discovered electrons. Nobody's talked about neutrons yet. So let's keep going in the story. Erwin Schrodinger. Now he's like, okay, so he's building upon this model and he's building upon this model. He says it's not really this nice, pretty ring system. It's more of a cloud where electrons can kind of be all over the place. So he discovered cloud electrons in 1926. So again, a little bit further away in time, but not too much further from 1913 to 1926. Only 13 years here. Okay, and then we had James Chadwick. Okay, finally we have our neutrons in 1932. So he said there's a tiny dense nucleus made of protons and neutrons. The cloud is the likely place where electrons can be found. He says electrons don't orbit like the planets do around the sun, and we can't really predict their path. So if you've ever watched a football game or a baseball game on TV, think of the whole atom is the size of a football stadium. And then the very center of it where the 50-yard line is, put a teeny tiny pencil eraser. So that goes back to the concept where we were saying earlier that Ernest Rutherford said atoms are mostly empty space. That's a lot of empty space if you've got a pencil eraser in the middle, and then the outside edges are the big giant edges of a football stadium. So there we are with our history lesson.